for dead birds, and we would take 4 measurements from each bird, putting the information into big ledgers.
Over the last few decades, David and other volunteers have collected over 100,000 dead birds across downtown Chicago.
When I first started, it was just a thought that here are these dead birds, we might as well at least make them useful for research and bring them back to the museum.
But he started to realize this was a serious opportunity.
It was only as the sample grew that we realized there were a lot of interesting questions that could be addressed using them.
And when scientists examined this huge amount of data, they started to notice something weird.
Birds over the last 35 years have shrunk.
And this wasn't just one type of bird.
The most amazing thing that they observed is that on all of the species, whether it was a thrush, a warbler, a sparrow, they were showing this declining size. And the question of just exactly why is an open one.
I'm Noam Hassenfeld, and this week on Unexplainable, why are birds and a whole bunch of other animals shrinking? Okay, Benji Jones, you wrote about these shrinking animals for Vox. How much shrinking are we talking about here? Is this like birds are barely shrinking, or is this more serious?
It's pretty significant. So they found that birds on average over this 40-year period lost about 2.6% of their mass, and a part of their leg, which they use to measure the change in size, also shortened by an average of 2.4%.
Yeah, I assume those kind of changes and like a 2.6% change, we would normally expect to see that over like a much longer period than 40 years, right?
I mean, I think so. Like when I think about evolution, for example, in the animal kingdom, I mean, that often takes place over thousands of years, certainly not over 40 years. So it's pretty wild.
Is it only happening in birds?
It's pretty widespread. So it's not just birds that are shrinking. I've come across studies that show salamanders are shrinking over time, fish, wood rats, deer, sheep, common toads. There are lots of things that seem to be getting smaller over time.
Scientists have any idea why animals are shrinking? What's going on here?
So there's no one answer for all these animals. There's still a lot we don't know, but scientists do have some guesses that might explain what's going on.
So what's the best guess we have to explain the shrinking here?
There's been a fair amount of research on birds and some studies on mammals as well that appears to link these shrinking animals to global warming, to climate change. Literally just the world is getting hotter, and that is what's causing this shrinking effect.
How does climate change make animals smaller?
There is this principle in ecology called Bergmann's rule. Essentially, across the range of a warm-blooded species, like a kind of bird or a kind of mammal, you will see smaller versions of that animal in hotter climates and larger versions of that animal in colder climates. One explanation for this has to do with how easy if you're small. And for softened butter, which always drives me crazy because I'm never planning ahead when I'm cooking, and so I'm like, damn it, I have to like soften this butter quickly, and I'll often like cut it into little cubes, and tiny cubes of butter soften faster because there's more surface area versus one larger stick.
So if you want to get rid of heat, it helps to be smaller and have more surface area relative to how big you are. I assume not being able to get rid of heat is bad, right?
Exactly. In a hot environment, because you would potentially overheat.
Where does this get complicated? Why is that not just, okay, case closed, it's getting hotter, animals are getting smaller?
One of the things that makes it complicated is that Bergmann's rule applies to warm-blooded creatures. So these are things that create their own heat. But it seems that there's also this trend that cold-blooded animals, so things like insects and amphibians, are also shrinking in response to warming. So it's not just about warm-blooded creatures.
So Bergmann's rule wouldn't explain why some cold-blooded animals are also shrinking.
Exactly. And when you start to ask kind of why, that's when there are lots of different theories that potentially apply, and we don't have that great of an idea.
why could cold-blooded animals be shrinking?
So if you look at something like frogs, what researchers have found is that when it's hotter, their metabolism speed up. That means that they are actually kind of growing faster, transitioning through life stages faster. So a frog goes from tadpole to baby frog at a faster rate, which just means that they are smaller by the time that they're adults and they don't grow much beyond there.
Okay, so is that the only thing that makes this shrinking animal question kind of hard to answer, that both warm and cold-blooded animals are shrinking?
Well, some animals are actually not shrinking and getting bigger as the climate warms, according to some research at least.
What kind of animals are getting bigger?
Yeah, so there hasn't been a ton of research, but I have seen a couple studies. One was on the American marten, which is this cute ferret-like animal, and then another was on the Eurasian otter, also a very cute animal. And one theory for why they could be getting bigger is that there's either more food available because there's longer summer or spring periods where food grows, or it could even be just because they're spending less energy trying to keep themselves warm because it's just more of an ambient, comfortable temperature outside.
Okay, so then why wouldn't that just lead to birds getting bigger too?
Yeah, that's a really good question. So it's just really hard to say why there is this variation. I think these examples are just helpful because they kind of poke a hole at this being this overall effect of shrinking. Like, it's just not the case.
So it seems like global warming could be changing the shape of animals over time, but we don't really know which rules apply to which specific animals and exactly how they apply. That's all, like, still unknown.
Yeah, I think that's a good way to put it.
And for the animals that are shrinking, do we know if we're watching evolution happen here? Like birds are evolving to be smaller, that somehow it's better for them?
Yeah, so that's the other big unknown, right? Like, I have seen some research that suggests that this is an evolved trait for some birds. In some way, being smaller is going to benefit them in a warmer world, which gets back into Bergman's rule. But for some animals, we know that when it's warmer during their development, they'll just get smaller. So that's not evolved; it's just happening as they're growing. So for frogs, for example, and other amphibians, that seems to be the case. And we know this because scientists can alter the temperature in a lab setting, for example, while they're just growing these different animals, and they see that they just don't get as big.
Got it. So this is rule, right? This is just happening to these particular.
Yeah, and that would be what scientists call like a plastic change. And so for cold-blooded creatures, it seems that these kind of like within lifetime changes might be responsible for the shrinking effect.
And I assume it's important to figure out kind of which one is happening here, whether a certain shrinking is evolved or whether a certain type of shrinking is during an animal's lifetime, right?
Exactly. And so if it's happening during an animal's lifetime, such as with frogs, that definitely can come with some serious consequences. When it's evolved, like what scientists think might be happening with birds, it's probably scary. But it's important to keep in mind that there are still limits of adaptation, and the climate is warming really, really fast right now, much faster than it's warmed in the past. So can these birds evolve to live in warmer climates fast enough? We don't know. And even more importantly is that some animals are getting smaller at a faster rate than others. Some animals
Just too hard to predict.
yeah, this is like a question that I feel like every time I write a story about how climate change intersects with biodiversity, I get to this point in the story where it's like, climate change is having way more complicated impacts than we imagined, and they're really hard to predict. And I feel like this is a perfect example of that. Like, it's so hard to understand how warming temperatures are going to affect these really complicated ecosystems. And so trying to predict what will happen to a given species is really, really difficult.
After the break, we try out some really, really difficult predicting. And not just 40 years in the future. We're going much, much further. That's next.
This episode is brought to you by Nespresso Professional. Designed to create meaningful moments of connection at work, Nespresso Professional delivers exceptional coffee every time. With variety at your fingertips, you're sure to satisfy every taste. Discover the right solution for your workplace today. Unforgettable coffee, meaningful connections. Nespresso Professional. Visit Nespresso.com/pro to learn more.
While other money managers are holding, Dynamic is hunting. Seeing past the horizon, investing beyond the benchmark. Because your money can't grow if it doesn't move. Learn more at dynamic.ca/active. Dynamic. Actively different.
Hey, Vox Media listeners, it's Mike Murphy. What happens when you get two political hacks who've been running campaigns against each other for forever and add a world-class journalist?
You get a big bar tab, that's what you get. This is David Axelrod telling you also get a great podcast called Hacks on Tap.
This is John Howman. I'll tell you what we'll give you. A weekly podcast that covers the news, the headlines, and also the longer-term trends driving our politics from the perspective of three guys who've seen it all from the campaign trail to the forward cabin of Air Force One.
Join us every week on Hacks on Tap
On the Vox Media Podcast Network.
Bird.
It's Unexplainable. We're back, and I'm here with producer Mandy Nguyen.
Hey.
Mandy, you've been hard at work producing this Shrinking Animals episode, and when we left off, we were talking about how hard it is to predict how these animals might end up changing in the future.
Yeah, but I really wanted to try and predict it anyway.
Okay.
Obviously, it's hard to predict the future, and it's harder the further you go out. But I spoke to a bunch of scientists about what future animals might look like, and I had some fun with it, and I made a little nature documentary of the future.
Okay, let's hear it.
The Earth, millions of years in the future. This blue planet still teems with life forms, but humans are not among them. Our dominion has ended, and other creatures have filled the open spaces that we have left behind.
The vast pools of carbon dioxide that we produced were retained in the atmosphere for tens of thousands of years, and that has resulted in a renaissance of green plants. And then without humans around to harvest them, plant life has flourished and diversified, and so we now have an atmosphere that's richer in oxygen than the one that we have now.
Plants have flooded the atmosphere with oxygen, reshaping life on the Earth's surface. Insects are especially affected.
Insects breathe not with lungs like we do, but with tiny tubes called trachea that are found throughout their body. And researchers hypothesize because of a problem with surface area to volume limitations.
But with more oxygen in the atmosphere, those limits may not apply. This is what happened millions of years ago in the late Carboniferous period.
Around 300 million years ago, we know there were dragonflies that were around the size of hawks and ants as big as hummingbirds.
Now, in the world of
tropical forest in the future. As you stumble through this forest, all of a sudden you see